the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the structure of the atom. In our previous lesson, we introduced the discovery of the X-ray and the ensuing study of radioactivity. We also discussed the discovery of the nucleus through Rutherford's gold foil experiment. Today, we will be examining the conclusions Rutherford came to while conducting the gold foil experiment and how this led to the discovery of the neutron. Let us begin. Previously, we showed the gold foil experiment and also explained that this is how Rutherford was able to discover the existence of the nucleus. Rutherford summarized his findings as follows. Since most of the alpha particles passed through the gold foil undeflected, most of the space in an atom is empty. Some of the alpha particles were deflected by small angles. This indicated the presence of a heavy positive center in the atom called the nucleus. Approximately 1 in a million particles were either deflected by a very large angle or deflected back at the source. This confirmed that the space occupied by the nucleus is quite small. From this, Rutherford was able to make some specific calculations about the size of the nucleus. Based on the angle of deflection of the alpha particles, Rutherford concluded that the nucleus of an atom is 10 to the power of negative 15 meters. The radius of the whole atom is about 10 to the power of negative 10 meters. Rutherford also suggested that negatively charged electrons surrounding the positively charged nucleus are like planets revolving around the sun. The only problem with this assumption is that it could not explain what kept the electrons in motion around the nucleus. Based on Rutherford's theory, the electrons would have to spiral inwards towards the nucleus for Rutherford's hypothesis to be true. In 1937, an English scientist named James Chadwick conducted an experiment which identified a new type of particle within the atom. Chadwick's experiment was not unlike Rutherford's gold foil experiment. He fired a ray of alpha particles from a radioactive substance called polonium towards a thin foil this time made of beryllium. The radioactivity of polonium was quite high, and as the particles passed through the beryllium layer, rays consisting of electrically neutral particles were released. These particles had a mass approximately equal to that of the proton. Students, we have now identified the three constituent particles of an atom. It is important that we understand the role of these electrons as well as their locations within an atom. Let us do an activity. You will be presented with a series of statements that have missing words. Please fill in the blanks with the most appropriate words to complete the sentence. You may begin.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. I am sure you had no difficulty with this one. Let us fill in the missing words to see if you got all the right answers. An electron is a negatively charged particle. Protons and neutrons are found within the nucleus. Neutrons have no charge. In 1937, James Chadwick discovered the neutron. Alpha particles are deflected by positively charged plates. If your answers match what we have listed here, you are correct. Excellent work. Let us do another activity. Here is an image of an atom. Can you label each of the particles that represent the atom?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, everyone. Let us now label the image together to make sure we located the 3 constituent particles of the atom. If you did this correctly, you will have labeled your diagram as follows. The neutrons and the protons are the bodies within the nucleus. The orbiting particle is the electron. Was this your answer? If not, be sure to review this diagram with teacher after the lesson. Students, this concludes our lesson on the discovery of the nucleus. We learned that the discovery of radiation and the conclusions of the Rutherford experiment helped James Chadwick to discover the neutron. We identified the location of the neutrons within an atom, and we described the beryllium experiment that led to its discovery. Now we have identified and labeled all the particles of an atom. Our next lesson will explore the atomic model, a tool we use to visually represent the different theories that exist on the structure of the atom. That is all the time we have for today. Our next 3 lessons will be conducted in class, so make sure you ask teacher if you still have any questions about the atomic structure. Until next time, thank you, teacher. Thank you, students.